My name is Brian Stowe, and I work for the University of Vermont Proctor Maple Research Center. I'm the Woodlands Manager and also the Sugaring Operations Manager. And right now, I'm the Sugaring Operations Manager. This time of year, we are definitely in sugaring. It's kind of a late season. It seems like it anyway, although actually it's been running since the end of February, so we've had a very long season. Our normal average end date is around the 15th of April, and that's today, but it looks like we're going to go for another week, maybe. And we're in record territory now. We've made more syrup than we ever have in the past. And right now we're standing in our sap collection area. It's the releaser room and also our reverse osmosis room. So we're collecting our sap from the woods. It comes directly into this room, into vacuum releasers, and they actually extract the sap out of our vacuum lines without losing vacuum on the system, and it allows us to maintain vacuum on the system and maintain our productivity basically after the trees. Once it goes into those chambers, we then filter it with these sap filter here. It then goes through a transfer pump and up through an ultraviolet light, which kills the bacteria, at least briefly. In this kind of temperature, it's about 60 degrees today. The bacteria is multiplying very rapidly. But that UV light allows us to store the sap a little bit longer, and it stays clearer that way. Once you get bacteria in your sap, you make darker syrup, which isn't a bad thing, but we have customers that like the lighter grades too, so we like to make some of the lighter grades, and then we make our darker grades later to try to satisfy everybody's taste. Once it goes through the UV light, it goes out into our raw sap storage room out there, and we have 3 660-gallon storage tanks. Once it goes into those tanks and we have enough to start up, I'll feed the reverse osmosis machine over here, which takes out about 78% of the water before we even boil, which reduces our energy demand tremendously. So we're only using about a half a gallon of oil per gallon of syrup. The concentrated sap from the RO goes upstairs into a 300-gallon stainless steel tank, and then we also collect the permeate water, which is basically mineral-free wastewater from this part of the process. We don't throw it away though. We collect that in a 1,000-gallon tank upstairs, and also we collect it out in the poly tanks, the plastic tanks out in the back. And we use that to back flush and wash the reverse osmosis machine. We also use it to clean our pans. And when you boil sap and make syrup, it super saturates the dissolved solids in the sap. And it's mostly calcium malate, and that calcium produces a scale, or a niter scale, and it coats all the pans. And it reduces the efficiency of the pan, but it can also scorch, and it can also warp and burn the pan. So periodically you need to clean the pans. And just now I switched sides. I reversed the flow of the sap in the front pan, because these 3 partitions were building up a lot of niter, and you can see the foam. I don't know if you want to come over and see it. Partitions here, you can see they're foaming quite a lot, and that usually indicates that there is niter or scale there. So I've reversed the flow, and the less concentrated sap is now flowing over those, and it should lift some of that niter, and then it'll start building up on this side. So it's kind of a balancing game. But after 1 or 2 more boils, I'll probably have to clean this pan. And there's a back pan that we're cleaning over there, and there's a front pan that we're cleaning over there. And we're using our permeate, and we're using our condensate, which is basically the hot water that condenses off the back pan here. And that condensate is very effective at cleaning niter or scale. We're recapturing heat off of our back pan and preheating our sap with it, and then we're collecting that condensate and using it to clean all of our equipment. Anything that syrup comes in contact with, the hot water is very effective at cleaning that off. And this rig is very energy efficient, as I've mentioned before, only using half a gallon of oil per gallon of syrup. And in the old days, we would go through anywhere from 25 to 40 cords of wood in a season. And now we're using between 500 and 600 gallons of oil. So still a fair amount, but relatively low compared to the old days. And that's mostly due to reverse osmosis and the efficiency of this rig. We have an automatic draw, which I have set to 219 degrees Fahrenheit. And once the syrup reaches that temperature at this probe. Actually, can't see it from that angle. There's a probe in the front pan, thermometer basically, that when the syrup reaches 219 at that probe, it'll automatically draw syrup here. Once I draw off a bucket, I'll put it over here in my finishing pan, where I will bring it back up to temperature and check the density, the color, and flavor, and then I'll filter it with this filter press here and run it into a stainless steel drum and hot pack it. And that will go to a packer, and they'll put it in the small retail containers for us. And after that, all you have to do is taste it. You're not going to see this in too many sugar houses. It's a pretty neat device. It's very expensive, but it's basically my stats board. It tells me how much vacuum we have out in the woods, so 23 inches of mercury, which is great. It also tells me how much concentrate I have upstairs, how much permeate I have upstairs, and how much raw sap I have downstairs. So just standing at the evaporator, I can see basically all the vital statistics of the sugaring operation from one spot. So lets me know if there's a problem, if a tank's going to overflow, or if I'm running dry on raw sap. Then it's time to go in and work with the RO. All right, over here by the window you can see basically how the season has progressed. We started making A medium, and we continued making some really nice A medium right through here until about here. We started making A dark, and then it actually lightened up again for a while, and then we went back to A dark. And then now at the end of the season, or near the end of the season, we started to make a little bit of A medium again. And actually this was very close to A medium, but the flavor is pretty robust at this point, so we have to call it A dark. Basically the flavor dictates the grade to a large extent. For grading, it has to have the proper color grade, basically light transmittance, but it has to have the characteristic flavor for that grade, and it has to be the right density too. But all the syrup is the same density, so density, color, and flavor.